When looking at a bit string like this, we need to understand what representation is being used so we know how to interpret this. Could this be a number, or is this like two characters, like A and C or something? Who knows? It doesn't really matter. But we can't interpret this bit string until we are told what it means. Same thing goes for a computer. When we create a variable and we allocate some space for some bits, and we create a memory location, we put some ones and zeros inside of it, we need to tell the computer how to interpret those bits. And we do that with a variable declaration. So the first time you declare a variable, you need to first tell the computer what type is being used. Is it a character? So is it interpreted as an ASCII string? Or is it an integer? Or is it some kind of floating point representation? So that's the first part that we need to tell the computer about how to interpret a set of bits. Next, we need to tell the computer, hey, anytime you see this phrase, that tells you we want to reference that variable. We want to access that variable. So whether it's character C or variable 1 or variable temp, we want to be able to access that thing when we want to. And so it's going to have an association of type and how to interpret it, but it also is going to have a name so we can talk about it more easily. Now the important thing about these names is they have to start with a character, so like the letter C or V. They can include numbers. They can have unique characters such as the underscore, but they're also case sensitive. So if I typed in capital VAR1 later in my program would have no idea what that means because case matters. It needs to be lowercase VAR1. Finally, the last part that we can do is either initialize, like setting variable 1 to 10, setting variable temp to 0, or we can not initialize. And that's going to depend on what you're going to want to use that variable for. Sometimes you want to initialize, sometimes you don't. And that's up to you in the program. But basically, the basic gist in all of this is that you're going to have different types and that you're going to tell the computer how to interpret certain variables. So, for example, if we say something is type int, it's going to be that processor's default 2's complement representation. That will vary based on the type of processor you're using. So sometimes it'll be 16-bit, sometimes it'll be 32. It doesn't matter. If you want a little bit more precision, you can say I want short, which is typically 16-bit, long, which is typically 32-bit 2's complement, or long, which is 64-bit 2's complement. If you don't want to have it in 2's complement, you only want positive numbers, then you're going to use unsigned. And then we have our two floating points, float and double. Double means double precision, so we have that 64-bit rather than the standard 32-bit IEEE 754. And finally, we've got this character, which will be 8-bit ASCII with the parity bit.